If you've seen my previous projects, you'll notice that all of them are built for websites. Now, there's nothing wrong with web dev content, but I wanted to spice things up a bit, make something that doesn't need a browser. That's why for this project, I'm going to be making a desktop application to help game developers. You see, back in my third year of college, I had this group project. We decided to make a top-down zombie shooter game, very original I know, and this was the first time I worked with sprites. I went in thinking it was going to be easy because it's a 2D game. We just move images on the screen. I mean, technically that is correct, but I forgot about the animation. In 2D games, things that move are represented using images called sprites. To animate a sprite, you first need to make different versions of it. It's easier to draw them side by side, so artists usually put them in a file known as a sprite sheet. The sprites are usually laid out in a grid, so the game has to jump from one grid square to another in order to give the illusion that the sprite is animated. This can be done using X and Y coordinates. Going back to my story, since our game had both the player character and the zombies, we needed a lot of sprites. Unfortunately, none of us put points in artistic skills, so we had to get our sprites from itch.io. I ended up purchasing this tile set that came with both character and interior models. We didn't need all the sprites, so I had to manually select and export some of them as PNG images. Then I used an online tool to pack them into a sprite sheet for our game. This process was very tedious, and at the time I was thinking, what if there was a tool that allows you to not only pack individual sprites, but also lets you include specific sprites from an existing sprite sheet. Now I'm going to be making that tool. Since my tool is not going to be running on a browser, I can't rely on web technologies to make it. And even if I can, I'm going to force myself not to use them. Why? Because no pain, no gain. If you've seen my previous videos, you know I'm not the type to reinvent the wheel. That's why I'm going to use a GUI framework to help me. Now the question is, which framework? I was thinking of using Python as my programming language, so I searched up the best GUI frameworks for it. I avoided the AI slop, the articles, and went straight to Reddit for personal recommendations. That's when I learned about Qt. Apparently, Python has two Qt libraries to choose from, PyQt and PySide. They're essentially the same thing with some minor differences, but PySide was developed by the creators of Qt, so it's the one I went with. Making desktop applications is completely new to me, so to be honest I was kind of lost. I did what any rational individual would do when learning something new. I went on YouTube and I looked up a tutorial.
That's why he's the MVP! That's why he's the GOAT! The GOAT!
After a good sleep, after watching the tutorial, I was ready to start making my tool. In my head, I kind of had an idea of what I wanted it to look like. You see, I was thinking of having a list of sprites on the right that would look like the layers panel you see in graphics design software. It's gonna have two buttons at the top, one for adding sprites to the list, and another for clearing the list. To remove individual sprites from the list, I'll create a context menu with a delete option. It will only appear when the user right-clicks on a list item. The area on the left will be called the preview. This is where I want the sprite sheet to be shown to the user. The user needs to be able to see every part of the sprite sheet, so I'm gonna add vertical and horizontal scroll bars, and also buttons to zoom in and out. My tool will be generating a JSON file, along with a sprite sheet that contains the position of the sprites in the sheet as well as their dimensions. I'm gonna call this file the datasheet. The user will be able to switch between this and the sprite sheet in the preview. Lastly, desktop applications usually have this horizontal bar at the top that has all the menus with useful options like create a new file or save the file. I'm going to implement one for my tool as well. It's going to have a file menu and a help menu. The file menu will have options to create, open, and save files, and of course a way to close the program. The help menu on the other hand will have a link to the project's repo and maybe to my channel as well to drive traffic, and also an option to open the tutorial. I'm not going to worry about the tutorial yet, I'll leave that at the end. There might be other features I haven't accounted for, but I'll just add them in as I go along. After deciding on the core features, I opened up VS Code, installed PySide, and created my very first window. That was very productive, so I decided to call it a day. The next day, I created the main sections and added the buttons for the Sprites List. I know, it doesn't look like much, but this actually took me a while to make because I wasn't used to Qt's way of doing things. You see, Qt's version of a HTML element is a widget, and there are many different types. If you're not familiar with UI terminology, it would actually be difficult to know which one to use. Qt also supports CSS, but it doesn't do everything the original one does, so it's more like a knockoff. Also, some styles can only be achieved by passing enums to setter methods. Not gonna lie, this type of styling made me realize just how ungrateful I am for CSS. Imagine styling websites using OOP methods. No thanks. Creating the sprites list was my next goal. I was thinking of showing the sprites as icons next to their file name, but there was one problem. I didn't have a single sprite image to use as a placeholder. So, I decided to create one. As you can tell, it puts the Mona Lisa to shame. With that, I was able to create a sprites list and populate it with fake items for development. I'm not gonna bother explaining how difficult it was to adjust the space between the icons and the names. I had to resort to using ChatGPT to generate examples for me because Qt's documentation wasn't helpful. After the sprites list, I implemented the file menu and the help menu. Qt didn't have an easy way to align the shortcut text to the right, so I decided to just leave the shortcuts like that. By now, my tool was starting to look like how I imagined it. The next thing I did was add buttons to the preview. You know, the ones for zooming in and out and for switching between the sprite sheet and its datasheet. I gave them icons to spice up the GUI. Then, I implemented vertical and horizontal scrolling. I even made a placeholder sprite sheet and added it to the preview to simulate the real deal. I thought I was done with this until... It turns out that centering things introduces a lot of problems. I only found the cause after changing the preview background's color to red. Fortunately, this was easy to fix. I just needed to resize the preview background and reposition the sprite sheet in the center whenever the main window itself is resized. It was now time to implement zooming. Initially, I thought this was going to be difficult, but it was actually pretty easy. The principle behind it is simple. When zooming in, the sprite sheet is enlarged along with the preview background. The latter is required because it increases the scroll distance, which allows the scroll bars to move across the entire sprite sheet. To zoom out, the opposite happens, but the background stops shrinking when the zoom factor reaches 1. This is because it can't be smaller than the area it's supposed to take up. By the way, the zoom factor is the decimal number I multiplied with the dimensions of the sprite sheet and the preview background. Values larger than 1 increase size, while values less than 1 decrease it. I set the maximum zoom factor to 8 and the minimum to 0.25. The default is of course 1. I added another button to the preview for resetting the zoom because I realized how annoying it was to zoom out from the max scale. Oh, and I also added text next to the buttons to show the current zoom factor in percentage. With all of that done, I can finally move on to the input mechanics. I figured I should start with the Add Sprites button. Remember in my long intro, I mentioned that I wanted to make a tool that can pack both individual sprites and sprites from existing sheets. What's that? You don't remember because you skipped it? Well, to allow both input types, I created this dialog. It lets the user choose how they want to pass the sprites to the tool. I don't have a way to store the sprites yet, so I'm gonna leave it like this for now. Technically, all I really need is a folder since they're just images, but the real problem is, how do I handle the storage of my tool's inputs and outputs? I could create a central folder for my tool where it can store everything, but that would mean I have to worry about where to put it in different operating systems, and how to distinguish the files for different sprite sheets. Another option is to implement project folders because their location will be up to the user. I can assign them to a single sprite sheet and have them only hold the files needed for that sprite sheet. I went with the second approach since that seemed like the most intuitive. To start off, I decided to rename the New Sheet and Open Sheet options in the File menu to New Project and Open Project. Then, I created the dialog that asks the user for a name and a location for the project folder. After the user clicks Create, the project folder is generated. For now, all it has is a subfolder to store the sprites. What happens if the user gives an invalid path, you ask? Boom, error message. Oh, and I implemented the open project option as well. Now that my tool has a way to store inputs and outputs and a way to access them, I can go back to the input choices. I did the selection one for now since that was the easiest. All it does is it opens the file explorer and lets the user pick out PNG images to add to the sprites list. This was so easy to do that I even went ahead and implemented the file menu option to close the project folder, which I totally didn't forget to do. Since I could now populate the sprites list for real this time, I decided to make its context menu. You know, the one that has the option to delete a sprite. Fortunately, Qt made this very simple to do. So now I can finally get rid of this. I didn't like how the context menu only had one purpose, so I added the option to rename a sprite. This changes the file name of the sprite, which means that even if I close the project and reopen it, the sprite will still have the new name. Of course, only valid file names are allowed. Long names, on the other hand, are shortened with an ellipsis. One more thing worth mentioning is that renaming can also be triggered by double-clicking on a sprite. Very cool, right? To finish off this whole renaming and deleting thing, I implemented the Clear All button. I added a confirmation prompt to protect against accidental clicks. You can thank me later. It was now time to tackle the thing that I've been dreading, the sprite sheet input option. I was thinking about it while I was working on the other core features, and hear me out, I may have come up with a clever way to extract sprites from sprite sheets. You know how sprite sheets are always organized like a grid? I figured, what if I scanned the pixels of each grid square, either row by row or column by column, until I hit the first non-background pixel? That non-background pixel will give me a coordinate, which I can use to determine the sprite's bounding box. Once I have the bounding box, I can make a copy of the sprite and save it in the sprites folder. Okay, now for the implementation. First, I made it so that project folders now have a subfolder to store files temporarily. When the user selects a sprite sheet, a copy of it will be saved in this folder. Next, I made a dialog that asks the user for information about the sprite sheet. It appears right after the copy is saved. The fields are kinda self-explanatory, so I'm not gonna talk about them in detail, but just know, I was trying to give the user the freedom to choose which sprites to extract. That's why I have this area to scan section. Also, the auto find button works by getting the most common color, which is obviously going to be the sprite sheet's background. The start button doesn't work yet since I haven't implemented the extraction algorithm, so I'm gonna do that now.
One eternity later.
Okay, I'm back. Did you miss me? The start button works now. Oh, and I added two new fields in the area to scan section. They allow the user to move the area to scan around the sprite sheet. Before, the user could only resize the area, but now they can change its position as well. This allows for precise selection of sprites. The extraction seems to work perfectly and is fast too, but I think that's just because my sprite sheet is small. Large sheets would probably take some time to process, but I added a progress bar just in case that happens. Okay, pause. I just want to point out that during this time, I forgot to make the extraction algorithm account for non-transparent background colors. I modified it later on to support all colors, so here's a demo from the future that shows me extracting sprites from a colored sprite sheet. At this point, the input mechanics are finished, so I can finally start creating sprite sheets. I began by adding a new button on top of the sprites list that opens a dialog with 5 layout options. These will determine how the sprites are arranged in the sprite sheet. I decided to do the compact option first since it's the hardest. Compact, by the way, means the gaps between the sprites are minimized. Remember, sprites are images and images are rectangles. I want to pack the sprites, so technically I'm dealing with a rectangle packing problem. When I looked it up, I was greeted with math. I'm not a math whiz, so instead of figuring out how to do this in code, I decided to use a Python library that can pack rectangles. The library was easy enough to use, but I ran into a problem. For some reason, the sprites were overlapping. I had to write a correction algorithm to fix this, which works by adjusting the sprite coordinates given by the packing library. All it does is it increments the coordinates of a sprite until it's no longer overlapping with another sprite. I tested the compact option with a large number of sprites and it worked, so I marked it as complete and moved on to the other layouts. They didn't take me long to do since the sprites only go in one direction. After finishing the layouts, I implemented exporting in the file menu so the user can download the sprite sheet. I replaced the saving options with exporting because it turns out the user didn't need to save anything. The datasheet export option is for downloading the JSON file that's generated with the sprite sheet. I mentioned it as one of the core features of my tool. Speaking of core features, I also intended to make the datasheet viewable in the preview. I can't believe I nearly forgot about it. Since I want the contents of the datasheet to be shown instead of the sprite sheet, I created another scrollable area that will replace the one for the sprite sheet. The difference between the two is that this one is only vertically scrollable. When I display the JSON data, this is what it looked like. As you can tell, it's hard to read. I added indentation to it, which was an improvement, but it still looked mid. So I looked up how to add colors to text in Qt and found that HTML is supported for label widgets. Well, maybe not the HTML I know. After playing around with it, I managed to turn that boring JSON string to this. Not gonna lie, I was very proud of the result. Now my tool is pretty much complete. All I have left to do is the help menu stuff. The links were the low-hanging fruits, so I did them first. Then, I began working on the tutorial. I created a separate window for the tutorial because I wanted users to still be able to use the tool while it's opened. As for the content, I only covered the important things like how to create a sprite sheet or how to use the dialog for extracting sprites. I didn't bother explaining what certain buttons do because they're all kinda self-explanatory. I mean, let's be real, you don't need to know what clear all does or preview sprite sheet. With the help menu done, my tool was now officially finished. I made an icon for it, then I bundled the codebase into an executable. I tested the executable on Windows and Linux to see if it was cross-platform compatible, and sure enough, it was. Okay, that's another project complete.
Watch the sunrise on a grateful universe.
The source code for this project can be found on my GitHub. It doesn't have a premium version, so the entire codebase is available for free. The downside is there's no installer, so you will have to clone the repo and build the executable yourself. Don't worry, I left instructions on how to do it. You just have to run a few commands. It's nothing scary, I promise. Are you still there? If so, please like the video and subscribe before you go. That's all for now. See ya.